Well, hello again, Phil here, and today we're going to talk about the general objectives. Riveting stuff. Anyway, let's see how we go. First of all, what are those general objectives? We probably know them pretty generally. People call them CAPS, MAPS, CAGs, but also the bottom one there. I think something we've got to touch on a bit more is the affective, and certainly my discussion with maths professionals is that really we want the kids to enjoy the beauty of maths and the why we'd use it and how cool it is, and to be able to talk about it. And that's that effective one. We don't assess it, but certainly it's an important one. So firstly, if we know in the syllabus that it says it's a mandatory part of the course that we have to assess the three general objectives: CAPS, MAPS and CAGs. First of all, if we're going to assess it, we certainly got to teach it. I thought that would be obvious. And what we need to do with those general objectives, we need to find out how well they meet those general objectives in their assessment. So I think we need to make sure that our lesson plans are framed around these general objectives. And I think we can use the content as the delivery of those general objectives, rather than just teaching content per se. Content's important. It's a mandatory aspect of the course. There's no doubt about that. But certainly we can use it to teach those very important general objectives. And certainly when you link that into assessment and exit criteria, you'll see how important that is. So first of all, knowledge and procedures. I've just listed them up there, just a grab from the syllabus. We can see there what the general objective of knowledge and procedures is. The Maths B ones, the bullet point at the bottom there is just the little addition for Maths C, and the only one that's different there for Maths A is that we have to use mathematical technology and geometric instruments as part of the knowledge and procedures. So have a look through there and you can see there's a lot of stuff there that really would make a lot of sense. Demonstrating number and spatial sense, demonstrate algebraic facility. They're pretty cool words. What do they mean? Good question. So a traditional example of what a CAPS question would look like. I'm not talking specifically here about assessment. What does a CAPS question look like? For example, in Maths A here, we might find the value of x in triangle ABC. An alternative might be in triangle ABC, use the tan rule to show the value of x as 8.4. And I think if you compare those two questions there, you can see where one of them is more pointed towards. I'm not focusing on the answer, but I'm really looking at the process. Another type of question we might ask in CAPS, but a bit of a controversial one would be if I had that triangle. Ask the question, what could you tell me about this triangle? And rather than having the x there, you might have a number there instead, and ask the students, what can you tell me about the triangle? And then they have to use the mathematical procedures to answer that question. Okay, another one that we might have in Maths B is and I've just changed the question here a little bit. Maths B would say use the chain rule to find the derivative of y equals sine x squared, as opposed to the question select an appropriate rule to find the derivative of y equals sine x squared. Have a look through the exit criteria in the tables at the end of the syllabus, and you'd see why sometimes you would say give them the rule, and sometimes that you wouldn't. And that's certainly how the differentiation between a level D and a level C type question. What does Maths C look like? Find the value of this matrix product, and hence predict the value of that and test the prediction on your graphics calculator. So you're asking them to perform the task of matrix multiplication. They can't just do it just using the graphics calculator, just with numbers. They've got to then start using algebraically, and so we might ask that CAPS question, and you know, where that fits in the learning. That's part of the wonderful world of teaching. When do you ask questions like that in the sequence of learning? We'll talk about that maybe another time. An activity I'd like you to think about now, if you want to stop the video and have a think about this, is what about the tools like Graphics Calculator or online tools like Wolfram Alpha? What impact would that have on how you might teach knowledge and procedures? There's not one answer to that. There's, but it's a good discussion point for you to have a think about. If we've got access to things that will find the antiderivative of a particular function without having to do anything with a full solution, what impact does that have on our teaching? So moving along, the second criterion, modelling and problem solving. I've just split it up a little bit here because the Maths A one is a little bit different from the Maths B one, and if you want to strain your eyes and have a look at the first two paragraphs in there, I think Maths A there is saying something pretty telling in terms of the it's sort of giving you some clues as to how they want this this criterion to be addressed. But certainly the actual wording then in terms of interpreting, clarifying and analysing problems, you'll find that in your Maths B and your Maths C one as well. And if we look back at some of our other modules, we've talked about in terms of modelling, the bullet points there in terms of identifying assumptions, etc., etc., the importance of modelling in our classroom, and the impact that will have then therefore on things like assessment. What does it look like? Here's an example of a MAPS type question now. On a particular day, you can read it, 23, blah, blah, blah. And then how many cases of flu would you expect after 10 days? Now, what do you notice about this particular question? Well, it's a worded question. I've even had people tell me the difference between CAPS and MAPS is MAPS are worded questions, CAPS are just directed closed questions, and that really is not true. I will talk about this a little bit later. It also requires students to do a little bit more than just work out an answer. They have to look at the information, then develop a model, etc., work out a strategy, and then once they've identified all of the key parts of the problem, we've talked about modelling before, how important it is for them to do all of those things in order to answer the question. Well, let's move on. So the teaching of the general objectives, I think, should be taught using the maths concept as a conduit. And here we go. If I give you that last problem to think about now, in terms of it was a nice closed problem, how are we going to ask the kids to answer open-ended questions? How would you modify that last question in order to make it open-ended? It's a nice closed question because it says after 10 days, etc. So if you want to have a think about that, stop the video, because coming up are some examples of what we can do. Moving on. Here we go. Here's how we can change that question a little bit. How many days would it be before the whole school was infected? So there we go. Before we start this little activity, we'd line up a kid or mention to a student that we'd say, listen, you're person X, you're it, you're our contagion. But don't tell anyone. Very secret squirrel tough. And so we pretty much say that on average humans on Earth, we've got 5 friends. So not 5 Facebook friends, because let's face it, some people have got 5,000 Facebook friends. and they're all close, good friends. Everyone in the class now shakes hands with 5 members of the class. We'll do it again, we'll do it one more time, and the symbolism of shaking hand is passing on that case of, or that dose of the flu. Now let's model it a little bit, and let's say that one person was it. Who did they shake hands with? Who did they shake hands with? And the third time, and then ask the question, how many handshakes would it take to infect the whole school? And depending on who shakes hands with who, we're going to get different answers, because we might shake hands with the same person and reinfect them or whatever. And so we can change that little problem there to be an open-ended modelling and problem-solving task. And then if I asked you then on reflection, how many of those bullet points do you think are being learned by the students by engaging in a modelling and problem-solving question like that? And I say modelling and problem-solving, not just solving problems. And you can see why it becomes a full modelling and problem-solving question. Do you think the students would enjoy that? I don't know. That's for you to think about whether those questions are those sorts of problems are good. Now this one is a contentious issue, and one that I really haven't come to a definitive answer. But if I gave a student a problem like that and I said, well, am I teaching here modelling and problem solving, or am I teaching knowledge and procedures? And the answer to that question is yes, you are. You're teaching both. So, you know, here's an example of where, you know, we're not sure. The question before, and what about this one here? To which objectives does this belong, caps or maps? Show how the sum of two successive triangular numbers is always square. Give an example to illustrate this property. And I think telling them there, give an example to illustrate the property then implies the students aren't to use just examples to show that it's true. Again, look seriously. In the past, when I've been a head of department, I used to have a part A and a part B. And part A, I chose to collect data or give students opportunity to show knowledge and procedures. And in part B, I've given them opportunity to show modelling and problem solving. However, if the students have demonstrated good knowledge and procedures in that part B, the modelling and problem solving, do I say then for that student then that they've achieved that objective? Why not? That's a good question. Lastly, communication and justification, the CAJs. First of all, it's got to be assessed globally. We can't set assessment tasks or set tasks or ask students to do questions that are just communication justification. It's something that's done globally. So across a term, across a week, across a lesson, and across an assessment instrument. So we're looking for our students writing stuff properly. And are they, very important at the end there, are they validating and justifying what they're writing? And again, if we're going to ask students to develop or to prove these things in the important stuff in terms of assessment, then it's behest of us to teach them how to do that. So presenting information properly and appropriately is something that we need to say to the students. I need to teach you how to do that. Doesn't mean to say we have to stand at the front of the room and teach them to do that, but certainly teaching them involves the craft of teaching. Love it. So how would we teach CAJs? First of all, they're going to copy exactly what you do. If you write an answer up on the board, they're going to do exactly the same. Just a couple of other techniques that we can use. We can do just a couple. You don't have to say this is a finite list. Find the error, do a jigsaw, and round robin. And I'm going to talk about a couple of those now. So here's a problem. Jackson's paid $30 an hour, so obviously not teaching. For a 35-hour working week, definitely not teaching. And he works overtime, he's paid at double time. How much will he earn if he earns if he works 40 hours. First of all, find the error. Students then have to find out where the mistake is, identify the error, and now correct the error. Now what we're doing for the students there is obviously modelling the best way to do it. All they're looking for is the error. Why would we do an activity like this? As I go back to, students don't look for errors. That's just what they do. They trust their answer. Let's move on to the next question, problem, or whatever they're doing. So by doing this sort of type of, teaching them how to structure work, then what we're doing is also teaching them how to edit their work. And certainly when I've been tutoring students in high schools, the one thing that I get the students to do is work on their communication and justification first. So find the error. Good activity. Jigsaw. What about if we made up all of these little bits of strips of paper, a little bit of work for us to do? What else would you be doing on a Sunday afternoon? Strips of paper, put them into a paper envelope or a plastic bag. Paper envelope would be much more green of us. And ask the students in a small group or individually or whatever to arrange them in the correct order. And here's a little chocolate bar for the group that gets finished first. What you're asking the students there again is to construct an argument, which is again, we're teaching them about using the proper wording. So when we've got what we've done modelling there with the words, then it's students will generally copy what we do. All right, something for you to think about again. Again, you might want to stop the video here and have a think about this. But what are the advantages of using these types of learning? And in what way do they support their learning? All right, I'm going to leave it there. We might have a chat again in our tutorials about the 3 objectives. So bye for now.